Welcome to another part of our video series about the air motor. After you successfully constructed all the individual parts with the help of our previous videos, today we dedicate ourselves to probably the most important step, the assembly. In this video, we will show you how to load the previously created components into an assembly and connect them in such a way that the function of the compressed air motor is ensured. Let's jump right in and bring the compressed air motor to life. We will now add the individual components of the pneumatic motor step by step and learn how to position and link them together. We start with a new design that we will save as the pneumatic motor. This construction is first created as a single part. Once we add multiple components to our construction, it is automatically converted into an assembly. We use the base plate as the foundation for our assembly. To do this, go to Insert and select Insert Component. As soon as the base plate is added, Fusion automatically positions it at the origin. Make sure that the check mark is activated at Fix to Parent Object. After confirmation, a small anchor on the component symbol indicates that the base plate can no longer be moved. Additionally, the symbol of the construction is adjusted to make it clear that we are now working with an assembly. Next, we add the mounting bracket. Again, use the Insert Component command. After inserting, you can easily move and rotate the component freely to facilitate the later connection. Take hold of a suitable point on the component and position it roughly so that the holes of the bracket are over the threaded holes of the base plate. Before you confirm, uncheck the box for Attach to Parent Object to keep the mounting bracket movable for now. You can still freely move the mounting bracket. Now, we will connect the mounting bracket to the base plate. Open the Assemble menu and select the Joint command. To perfectly connect both parts, first select the lower circle of a hole of the fastening bracket. Make sure that the snap with the small coordinate system on the lower surface of the fastening bracket is within the hole. Pressing the Control key can help us position the snap more easily. Then, select the corresponding hole on the base plate. Here too, the snap should appear on the upper surface of the base plate. In the next step, we define the connection type of the joint. Choose the type Rigid. This restricts all degrees of freedom of the mounting bracket, so it can neither be rotated nor moved. If the mounting bracket is not perfectly positioned yet, you can adjust this by changing the angle under alignment. With the arrows at the very bottom of the menu, you can adjust the direction of the mounting bracket if it was positioned incorrectly. Once the components are perfectly aligned, confirm the joint connection. A look at the construction history shows that we have already successfully completed 3 assembly steps. We have inserted 2 parts and firmly connected them with a joint. You can change the joint settings at any time by selecting it in the timeline. Alternatively, you can find all joint connections in the Joints folder in the browser. Congratulations! You have successfully created the first connection in your assembly. In the next step, I will show you more types of joints to connect the remaining components of your air motor. Next, we will insert the engine block into our construction. This time, we will use the File panel to load components into the assembly more quickly. Simply drag the engine block from the File panel into the construction. Precise positioning is not yet required at this point. First, roughly move the engine block so that it is approximately in the right place. To firmly connect the engine block with the mounting bracket, we use the joint function again, which you can find under Assemble. Our goal is to precisely align the holes of the engine block with the holes of the mounting bracket. First, select the borehole of the engine block. Ensure that the snap is displayed within the borehole on the surface that will later be connected to the mounting bracket. Repeat the process for the corresponding borehole of the mounting bracket and ensure that the snap is also correctly positioned here. In the next step, we will once again determine the type of connection. Under Motion, select the type rigid from the drop-down menu. Here too, this connection ensures that the engine block is firmly attached to the mounting bracket and can no longer move or rotate. If the engine block is not yet correctly aligned, you can finally adjust the alignment using the angle adjustment and reverse function. When everything fits, confirm the process. The engine block should now be firmly connected to the mounting bracket and should not move anymore. Well done! Let's continue. Now we will insert the piston into our assembly. Drag the piston from the file panel into the construction and confirm the placement with Enter. To connect the piston with the engine block, we activate the joint command, this time using the keyboard shortcut J. Since we use this function often, this shortcut will save us quite a bit of time in the future. For the connection, first select the outer surface of the piston, then click on the large hole in the engine block. In the menu, we set the connection type to cylindrical. The animation preview shows that the axis of the piston automatically aligns with the axis of the bore. This cylindrical connection allows the piston to move along the bore axis and rotate around this axis. Exactly the mobility we need for the function of the piston. If that was too fast for you, you can check the selected type of movement and axis again in the joint menu under Motion. You also have the option to preview both the rotational and vertical movements here. Additionally, you can define movement restrictions, such as a maximum height, to ensure that the piston does not move too far up or down. In this case, that is not necessary, as the piston will soon be limited by the pleuel. With this step, the piston is correctly connected to the engine block. Very well done. Let's continue with the crank. After we have loaded the crank into our construction, we first roughly rotate and move it again to facilitate the next steps. This way, we can connect the components more quickly and precisely later on. As before, we activate the joint command with the J key. Now we select the two large holes that will later accommodate the crankshaft. One on the crank and the corresponding hole on the engine block. Make sure to mark the two surfaces that are meant to later lie directly on top of each other. For the crank, select the surface of the step, and for the engine block, choose the corresponding bore surface of the front view. In the drop-down menu, we set the connection type to Revolute and confirm the selection. Fusion automatically aligns the components correctly. The crank is now perfectly positioned and aligned. It can only rotate around the axis of the crankshaft as required for its function. Now we add the crankshaft to our assembly. Drag it into the design as usual to insert it. Next, we activate the joint command again with the J key. To precisely connect the crankshaft with the crank, we mark two circular surfaces that should align exactly, one on the crank and the corresponding surface on the crankshaft. This time, we select Rigid as the connection type. This setting ensures that the crankshaft is firmly connected to the crank and no independent movement is possible. To ensure the crankshaft is directly aligned correctly, we keep the angle in the connection settings at 0 degrees. Fusion ensures that the crankshaft is correctly positioned and connected to the crank without twisting. When we turn the crank now, the crankshaft should automatically rotate with it since both components are rigidly connected. With that, we have successfully completed another step in the assembly. Let's move on to the next connections. Now it's getting exciting. We bring the heart of our compressed air engine to life. To do this, we connect the crankshaft with the piston and insert the central components, the connecting rod, the pin, and the crank pin. We first bring these into our assembly group and begin step by step with the assembly. First, we connect the crank pin with the crank. Use the joint command, which you activate as usual with the J key. Again, make sure the catch engages the correct surfaces. We select Revolute as the type of connection. This way, the crank pin is securely in the crank and can rotate with it around the axis later. In the next step, we connect the pin with the connecting rod, also using the joint command. Make sure the snap point is set precisely at both the bore of the connecting rod and the middle of the pin. Here too, we choose the type of joint Revolute, allowing the pin to move freely within the connecting rod. Next, we proceed with the connection between the connecting rod and the crank pin. Use the joint command again, select the corresponding surfaces and set the connection to rotation. This allows the ploil to convert the rotational motion of the crank into a linear up and down movement. Finally, we connect the pin and thereby also the connecting rod with the piston. For this, we use the cylindrical type of joint, as this connection allows the necessary mobility for power transmission between the piston and the crankshaft. If all the connections have been set correctly, you can now turn the crank and observe how the piston moves up and down. Congratulations! The heart of your air motor is working perfectly. Next, we add the flywheel. Drag it into the assembly and connect it with the rigid joint directly to the crankshaft. This ensures that the flywheel moves together with the crankshaft. Be sure to select the correct surfaces here as well to ensure the position is right. With the flywheel, we have installed the last rotatable component. Now, only the cylinder head plate and a few standard parts are missing to complete the engine. First, we check if the air motor fulfills its purpose and if all components are correctly interconnected. For this, look in the folder Joints for the joint between the crank and the engine block. Right-click to open the context menu and select the option Animate with Joint Relationships. We see how the compressed air engine starts moving and all moving parts perform their tasks. By pressing the Escape key, we end the motion preview. We insert the cylinder head plate into our construction as usual. Drag it from the File panel, place it roughly, and open the joint command with the J key. Select a hole in the cylinder head plate and the corresponding hole in the engine block to connect the two components. Ensure that the snapping point is on the connecting surfaces so that the plate is precisely positioned. We choose rigid as the joint type to firmly connect the cylinder head plate with the engine block. If the alignment is not correct, you can adjust the angle settings and direction until the plate rests properly on the engine block. Let's continue with the screws to fix the cylinder head plate. To do this, open the Insert menu and select the Insert Fastener command. If you have rotated your components while assembling, you can restore the original position of the components beforehand. In the window that opens, you can select standard parts like screws, nuts, or washers. Directly search for DIN963 to find a suitable countersunk screw. We decide on an M3 screw with a nominal length of 6 mm. We leave all other settings at their default values and confirm to insert the screw into the construction. Next, we position the screw using the joint command. Select the screw head so that the snap point is correctly positioned and align the screw with the countersink of the cylinder head plate. Here too, we use the joint type rigid to precisely fix the screw in the hole. To save time, we do not need to insert the remaining screws individually. Instead, we can simply duplicate the first screw with its joint connection. For this, we select the duplicate with joint command from the Assemble menu. Highlight the previously placed screw and then choose the other 3 countersunk holes of the cylinder head plate. Fusion automatically creates 3 new screws, which are directly fixed with the joint connections to the corresponding holes. Now all screws are correctly placed and the cylinder head plate is securely connected to the engine block. Now, we insert the remaining screws to securely connect the mounting bracket with the engine block and the base plate. For this, we reopen the Add Screw command and specifically search for DIN 912 to select the appropriate hexagon socket head screw. Once the screw is displayed, we adjust the properties. We select a thread size of 4 mm and a length of 6 mm. This time, we move our mouse directly into the workspace without confirming beforehand. We see that the screw is displayed directly for precise positioning. We place the screw on a hole in the mounting bracket. The preview shows us that the screw is directly added to the other 3 holes. Once the positioning fits, we confirm with a click. We repeat the same process for the screws between the mounting bracket and the engine block. In this case, it can be helpful to hide the base plate. When all screws are correctly positioned, we close the Standard Parts window. We see that our last screw connections have been grouped together. However, to make the design process even clearer, we want to combine all screw connections into a single group. To do this, we delete the existing group with a right-click. We select the first option to dissolve the group while keeping the screw connections. Now we select the first step where a screw was inserted, hold down the Shift key, and click on the last step where a joint connection was set. This will mark all relevant entries. With a right-click, you open the context menu and select Create Group. The screw connections are now combined in a clear group. You can expand the group at any time to make adjustments or changes. With these steps, we have positioned the screws neatly and organised the construction progress. Now, all that is missing is the retaining ring to secure the crankshaft. We download this directly into Fusion via McMaster Car. To do this, we click on Insert and select Insert McMaster Car part. Through the McMaster Car catalogue, we have access to a large selection of CAD files specifically for standard parts. To find the appropriate retaining ring, we enter the part number 98541A112 in the search bar. The required ring is displayed to us directly in the catalogue. We select a 3-dimensional step file as the file format and confirm the entry using the download button. As with the screws, the retaining ring is loaded directly into our design. We could also simply place these using the joint command and fix the joint type rigidly. Perfect. All parts are firmly connected to each other. Don't forget to save your compressed air engine again. Congratulations! You have successfully assembled your air motor. In the process, you learned how to precisely insert and position individual components and screws in your design. Additionally, you learned various methods to accurately align and connect components using joint connections. In the next video, we will show you more exciting features that you can use in assemblies. This also includes the ability to impressively display the movements of the air motor. Stay tuned, it remains exciting. See you in the next part. Have fun exploring.